how fast is this going to be going?
16. Is it negative 16?
How'd you get that?
Oh, sorry, I was looking at 10. I mean, negative 7.
Yeah, it'll be going at -7, so the momentum is -70. So my total momentum is -70 Descartes. So by changing the observer, I can change the amount of total momentum. Let's stick it here. V equals 0 meters per second. V equals -7 meters per second. Now, as the observer, if I'm doing -1 meters per second, how fast is this one going?
0.
And how fast is this one going?
5 meters per second.
Middle.
9 meters per second.
So it's going 6 meters per second that way relative to what's called the lab frame. I'm going this way at 1 meter per second.
7.
7.
Yeah.
So the momentum in this case then would be 28 Descartes. And so we have a total V final, RP initial, and V final. Notice that to find how fast it's going, all we did was take this velocity and subtract how fast the observer was going. So 6 minus 6 is 0. -1 minus 6 is -7. Here, 6 minus -1 is 7. -1 minus -1 is 0. So if I were going 2 meters per second, what would its velocity appear to be?
4 meters per second.
Which gives it 16 Descartes. And this one?
-3 meters per second.
Thank you. Which is -30 Descartes, which gives us a total of -14. What I want to do is find the reference frame, find out how fast the observer needs to go, or what the velocity of the observer is, so that my total momentum is 0. Well, I know it's got to be somewhere in between there, because that's positive 14 and that's negative 14 for total. Now mathematically, what the way you solve it is, I want my total momentum to be 0, and that's going to be equal to 4 times 6 minus V for my variable, plus 10 times 1 minus that V. Sorry, -1 minus V. And just solve. So I get 24 minus 4V minus 10 minus 10V equals 0. I've got 14 minus 14V equals 0. 14V equals 14. V is equal to 1. If the observer is going 1 meter per second, the total momentum is 0. Where have we seen that 1 meter per second before?
First time we did it.
What was the problem?
Inelastic.
Perfectly inelastic. This will always be the solution to the perfectly inelastic collision. Typically, on the test, I give you, the first question is, if it's perfectly inelastic, what's the final velocity? And then if it's perfectly elastic, what are the final velocities, plural? And so if you've already done the first one, you don't have to redo it. So we start out in what we'll call the lab frame, or the problem frame. 4 meters per second. Sorry, not what I wanted. It's my 4 kilogram mass and my 10 kilogram mass. It's starting out going 6 meters per second and negative 1 meter per second. We're going to shift to the zero momentum frame. So we'll subtract 1, so minus 1. Minus 1, minus 1. So this is going 5 meters per second. This is going negative 2 meters per second. So this is the shift. This is the zero momentum frame. Then they collide. I want a situation, my total momentum is 0. I want to know what are the final velocities so that my momentum stays the same in this frame and the kinetic energy stays the same. Well, it's really convenient if the speeds stay the same. So, collision. If all they do is just switch signs, each speed stays the same. So my kinetic energy doesn't change. If my momentum will just flip to negative 0, which is the same as 0. So this is zero momentum frame. I need to shift back into the lab frame. I subtracted 1 to get out of it, I add 1 to get into it. And then we have our answer. Negative 5 plus 1 is negative 4 meters per second. 2 plus 1 is 3 meters per second, and that's the exact same solution. Which technique you use to solve this, I don't care. My recommendation is pick one of the methods and learn it. I find this is the simplest mathematically, but it's a little bit more abstract. So which one you like, it's up to you. But pick one, learn it. And have a wonderful weekend.